Okay, so now I'm going to explain the action potential and some important definitions behind it. So, some of the important things you need to know are listed here. So, for example, depolarization is when the membrane potential becomes more positive, alright? Which can also be classified as excitation because it's the beginning of the action potential and the stimulus, alright? And then hyperpolarization is essentially the opposite of that, and it happens when the membrane potential becomes more negative, and it can also be known as inhibition. Repolarization is simply when the membrane potential returns back to resting membrane potential. Okay, so when we're looking at the action potential diagram as well as the definitions, try to not think too much into it with regards to physics when you thought about a polarized molecule and a non-polarized molecule, because it's a completely different thing and it kind of confuses students in the beginning. So essentially, this is what your action potential looks like graphically. And what happens is you start off at your resting membrane potential, which is at about negative 70 millivolts. And then something will happen, a stimulus will happen. So maybe a hormone will be released and then that will stimulate your ligand-gated channels, which I mentioned the different channels in a previous video, make sure you check that out. And then that will cause an influx of sodium ions, alright? Which will cause the membrane potential to become more positive. So there are some stimuli that can happen where it's not going to stimulate it that much, alright? You need a stimulus that's going to stimulate your membrane enough to get it up to the threshold value, which is at negative 55 millivolts. Once this happens, at negative 55, your sodium voltage-gated channels open. Now, essentially, these are just channels which will allow sodium through, and the only way they can be open is at a certain voltage. So in this case, it's minus 55 millivolts. So what happens is, those channels open, and there's a massive influx of sodium ions, which causes depolarization. So it causes your membrane potential to become more positive, up until a peak value, which is at positive 30 millivolts. And then at your peak value, which is known as your peak potential, you'll get your sodium voltage-gated channels closing and potassium voltage-gated channels opening. So now what's going to happen, because you remember that in the cell there's a high concentration of potassium ions, so what they're going to do is, if those channels open, the potassium ions are going to move from inside the cell to outside the cell. And because potassium ions are positive, with them leaving, they're going to bring down the membrane potential of the cell, in a sense making it more negative, which is what we define hyperpolarization as. So after that happens, so as your sodium voltage-gated channels have now closed, your potassium voltage-gated channels have now opened, there's an efflux of potassium ions, making your membrane potential drop. In some cases, it will drop past your resting membrane potential. And then when it gets down to negative 90 millivolts, this is when the potassium voltage-gated channels close, because it's becoming too negative inside the cell now. So now once those are closed, all the voltage-gated channels are closed now. So this period where your membrane potential returns back to your resting membrane potential is just purely due to the leak channels, which is the normal movement of potassium and sodium ions, and then your sodium-potassium pump as well coming into effect. So if we go back to our definitions briefly, I've numbered the points on the graph and how they can be related to the definitions. So depolarization occurs from point 1 to point 3. Because that's when the membrane potential is becoming more positive. And then hyperpolarization is from point 3 to point 4. So from here to here, because that's when the membrane potential is becoming more negative. And then repolarization is when your membrane potential returns back to your resting membrane potential, which happens between 4 and 5. Also, in a sense, not to overcomplicate things, but repolarization is also actually occurring here, from point 3 all the way down until your resting membrane potential, but not further than that, if that makes sense. That was just an added information just to help out. So this is essentially how an action potential is created. There's a stimulus which affects channels which open and allow different movements of ions into and out of the cell, which creates a spike, which will then stimulate other things to happen. In the neurons, it will stimulate the message to be sent along the axon, and that's how nerves essentially work as well.